Okay, a quick bit of conceptual understanding for small angle approximations. If we look at the graph of sine of x, we notice that when x is small, we almost get a straight line. In fact, when we set x to be in radians rather than degrees, that line is y equals x. And what we can say is when x is small, x is approximately equal to sine x. And we can just see that from the graph, but if we plot it out, you see it really accurately. Okay, so if we start again, this time looking at cos x, it kind of looks like a like sine x, like just a parabola drawn but upside down. So actually, if we calculate the parabola that looks really close to cos x at that point, turns out it's minus a half x squared plus 1. And since the red line is y equals cos x, and we're looking at x when it's small, we can say that cos is approximately equal to minus a half x squared plus 1. Finally, if we draw the graph of tan x and we look where x is close to 0, we can also see something of a straight line going on there. And if we figure out the equation of this straight line, when we measure x in radians, we get y equals x. And y equals tan x is the other line. And since they're very, very close, around the point where x is small, we can say x is approximately equal to tan x. And this is our justification, along with a whole bunch of other more complicated maths, as to why we can use these small angle approximations in our working. It's important to remind everybody that we need to work in radians to do these small angle approximations. We cannot be working in degrees. Okay, a quick practical example of how you will use this. First of all, sine of 2 theta is just whatever you're doing sine to is what you get, so 2 theta. And the same with tan and theta as the denominator. Thetas cancel, leaving you with just 2 theta as the answer. Okay. So here we replace sine with just sine of theta with theta, and tan of 5 theta with just 5 theta. It's all over 3. Nice and straightforward. We do cos of 2 theta, remembering to wrap 2 theta in brackets before we square it, then adding 1. We then add the terms together in the numerator and cancel the factor of 3. The negative remains in that first term. We haven't squared it away. And when we expand the bracket, we're going to get 4 theta cubed plus 2 theta. Now the factorised version of this is fine. But this is the expanded version.